I will be presenting our contribution at the CLEF HIPE shared task. So SinNer, it's a little joke. It's Sorbonne University for the S, IN is for INRIA, and NER is obviously NER. So yeah, it was a fun name. First, I will be presenting the rationale of our approach. Then I will present the models we used, the official results, and some studies we did before and after the official runs. So before we studied the sequence segmentation, and after the runs we tested whether adding dev to train data was useful or not. Okay, so we worked on coarse grain net entity recognition and classification, mainly because it was our main interest of study. Like we have the most experience in that, and our rationale is to really minimalize pre-processing. For example, we did not modify the text, so we did not normalize orthograph. We didn't try to correct OCR errors. Since we used contextual word embeddings that use subword to model words, we saw that it was the job of the neural architecture to deal with this. And what we did when it was possible, we studied sequence segmentation, which was modified when we had readily available tools that we had our hands on to have more meaningful context for words. And we compared our architectures on French and German. We did not try English because our methods implied a train set, which was not available for English, so too bad. And yeah, studying the influence of DES as a training data. So here is a noise example from the OCR output. So letters from some stuff and Germans, which would be translated to Suisse allemande if OCR was 100% correct. So we thought that OCR errors may have patterns, and since we use subword embeddings, that those patterns may be detected by our neural architecture. So we left everything as it was, and yeah, we let the neural architecture work with it. So our models base contextualized word embeddings we use was ELMO, which is for each word we use a character convolution neural network to have subwords, like n-grams for each word. And then each word will be represented as its n-grams. And we input those subword representation to a bidirectional LSTM to have a left and right contextualized word embedding at the end. So R1 is the final contextualized word embedding. And the whole architecture to provide outputs for the data is the implementation, the UFO implementation of bidirectional LSTM with LSTM-CRF, which was first presented by Guillaume Lampel. So it's basically the concatenation of multiple word embeddings. So we used here, you can see the ELMO, which was an ELMO model trained on French on the Oscar corpus, which is a deduped common crawl subset of French, where language was identified for French. We used the fast text embeddings, so the official fast text embeddings and not the shared task fast text embeddings, because we tried and we did not improve results. and a bidirectional GRU character level word embedding. So we concatenate all this, and we have a big embedding for each token. And then we just go through a bidirectional LSTM and a CRF layer. And we have our output for each token in a sequence. So we didn't use BERT because our sentence segmentation in French exceeded the BERT token limit, which was 512. So we didn't use BERT for this. And when we managed to do something, BERT didn't improve the results. So yeah, we opted out BERT. And for German, we just use the German ELMO model by May, which was trained on Wikipedia. So the official results, we did minimal model adaptation. So we used SEM, which is a CRF-based NLP tool I've been developing since an eternity, or what feels like an eternity, for sentence segmentation. And it works on local rules, based on local rules to have. So in French, we had sentences to have more meaningful context. And we optimized on dev to find out the best architecture or combination of embeddings. And in German, since SEM does not provide sentence segmentation for German, we left segments as they were. So here are our results compared to the winner and the average and the median results of all the participants. So I think that team-wise, we were third on both German and French. Correct me if I'm wrong. So we're near 80% of strict F1. So we use only strict F1 because it's like we work on text and it's like our cultural bias. So we have pretty decent results. The difference between run 1 and run 2 is that run 2, we broadcasted every named entity we found, every mention we found, we broadcasted it at document level. So if we find, for example, Johan Dupont somewhere in the document, and it's not found somewhere else, we just broadcast Johan Dupont as a person in the whole document. So unexpectedly, using sentences instead of segments yields a very decent improvement, like 4.5 points, F1 points in a strict F measure. I'm sorry, I don't have the fuzzy results in hand. And it improves both recall and precision. So recall, multiple segments split an entity in 2 or 3 or 4. So I think well, the reason is we have now a better representation, and entities are not split, and thus the context is better used to find those entities. And we also try to add development sets to train data. So you should not do this. Please do not do this. However, it works, and it works especially if your results are not, well, the lower your results, the best it will work, obviously. But as we can see in French, for example, we do not have a huge improvement, like only half a point in F1 score. And this improvement is not very interesting because it does not make any difference. Like there is no difference in ranking. So yeah, it's useless basically. So do this. So to conclude quite quickly, so the sequence segmentation is important, and this goes well with the previous presentations that concluded the same thing. And the system used to tackle the task seems to be the most important part of it, obviously. more so than like trying to grab points little by little by adding dev sets or not. And that today neural network architectures are very efficient, even if you do minimal adaptation. Like you can have very decent results, basically just plugging in your neural architecture to the task. Thank you.